Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC, this angle equals to 60 degrees, and we also know that BF equals to CF, BF equals to CF equals to DF that equals to EF. And we also know that triangle BDF, this triangle is 8 square units. The area of triangle BDF is 8 square units, and the area of triangle FEC is 15 square units. And we want to find out the area of the green shape, or the area of the green quadrilateral ADEF. So first of all, we will define angle ABC as B, and we will define angle BCA, this angle, as C, and we actually have a rule 1, or rule number 1, that states that the sum of the angles in a triangle the sum of the angles in any triangle is equal to 180 degrees. So I will read rule number 1 again. Rule number 1 states that the sum of the angles in any triangle is equal to 180 degrees. So, and especially the sum of the angles in triangle ABC is equal to 180 degrees. Therefore, angle A that equals to 60 degrees plus B plus C must be equal to 180 degrees according to rule number 1. 60 degrees plus B plus C equals to 180 degrees. So we will subtract 60 degrees from this equality, and we will get that equation number 1, that B plus C equals to 120 degrees. Okay, B plus C equals to 180 degrees. And then we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So I will read rule number 1 again, rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually, if we have triangle ABC, and we know that side AB equals to side AC, AB equals to AC, then so side AC equals to side AB, then according to rule number 2, in front of equal sides there are equal angles. So in front of AC we have angle ABC, and in front of AB we have angle ACB. So according to rule number 2, angle ABC equals to angle ACB, because of the fact that in front of equal sides there are equal angles. So those two angles are located in front of equal sides, therefore they are equal to each other. That is to say, angle ABC equals to angle ACB. Okay, so according to rule number 2, if we relate to triangle BDF, in triangle BDF, we know that BF equals to DF, BF equals to DF, and in front of side DF of triangle BDF we have angle B. So in front of BF the angle must be also equal to B, because those two angles are located in front of equal sides, therefore they are equal to each other according to rule number 2. So if this angle is B, then this angle must be also B. So those two angles are equal to B, and the same thing is true in triangle FEC. In triangle FEC we know that FE equals to FC, and in front of side EF we have angle C. So in front of FC the angle must be also equal to C, because of the fact that in front of equal sides there are equal angles. So in front of those two angles are located in front of equal sides, therefore according to rule number 2 they must equal to each other. So if this angle is C, this angle must be equal also to C. Okay, in the next step we will define angle BDF. BFD is P, and we will define angle CFE. This angle is Q, and we will express angles P and Q by B and C. Okay, and again in triangle BDF, the sum of its angles is 180 degrees according to rule number 1. So B plus B plus P equals to 180 degrees. Or 2B plus P equals to 180 degrees. Again, in this triangle BFD, the sum of its angles is equal to 180 degrees. That is to say, B plus P equals to 180 degrees. That is to say, 2B plus P equals to 180 degrees. And if we subtract 2B from this equality, we will get that angle P equals to 180 degrees minus 2B. Okay? And we'll do the same process about Q. Actually, in triangle EFC, the sum of the angles is equal to 180 degrees. That is to say, C plus Q equals to 180 degrees, or 2C plus Q equals to 180 degrees. Again, in triangle DEFC, the sum of its angles is equal to 120 degrees. That is to say, 2C plus Q equals to 180 degrees. And if we subtract 2C from this equality, we will get that Q equals to 180 degrees minus 2C, and we have already found out that P equals to 180 degrees minus 2B. Okay, so we have the values of Q and P. In the next step, we will add Q and P. So Q plus P will be equal to 180 degrees plus 180 degrees equals to 360 degrees minus 2C minus 2B. So here we will take a common factor of minus 2 from this expression. We have minus 3 in this number and minus 2 in this number, so we'll take out minus 2 as a common factor of this expression, and we will get that Q plus P, that will be equation number 2, Q plus P equals to 360 degrees. Minus 2 is a common factor, and inside the brackets we will have B plus C. Okay? Q plus P equals to 360 degrees minus 2 times B plus C. But we have already found out that B plus C equals to 120 degrees. According to equation number 1, B plus C equals to 120 degrees. So we actually can substitute B plus C in equation number 2 by the value of B plus C in equation number 1, or we can substitute B plus C by 120 degrees. B plus C from equation number 2, we will substitute it by 120 degrees from equation number 1. So we will get that Q plus P equals to 360 degrees minus 2 times, and instead of B plus C we will write down 120 degrees. So in total we got that Q plus P equals to 360 degrees minus 2 times 120 degrees. 2 times 120 degrees is 240 degrees, so we will write it down. So Q plus P equals to 360 degrees minus 240 degrees. So actually Q plus P equals to 360 degrees minus 240 degrees is 120 degrees. And we have already found out that B plus C, from equation number 1, that B plus C equals also to 120 degrees. Okay, so we have equation number 1 that states that B plus C equals to 120 degrees, and also Q plus P equals to 120 degrees. Okay, so in the next step we will find out the size of angle DFE. The size of this angle, and we will find out the size of angle DFB, this angle, according to rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. So I will read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So we will implement this rule in order to find out the size of angle DFE. Actually, BC is side of triangle ABC. Therefore, BC is a straight line, and the sum of the angles at point P is equal to 180 degrees according to the sum of the angles at point F is equal to 180 degrees because BC is a straight line. So actually P plus Q plus the size of angle DFE is equal to 180 degrees according to rule number 3, again P plus Q plus angle DFE is equal to 180 degrees according to rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees, and actually BC is a straight line, so the sum of the angles on this point F must be equal to 180 degrees according to rule number 3. So we have already found out that P plus Q equals to 180 degrees according to question number 2. P plus Q equals to 120 degrees according to question number 2. So we actually can substitute P plus Q of this equality by 120 degrees. So instead of P plus Q, we will write down 180 degrees plus angle DFE equals to 180 degrees. So we will substitute 120 degrees from this equality, and we will get that angle DFE is equal to 180 degrees minus 120 degrees is 60 degrees. So we found out that the size of angle DFE is actually equals to 60 degrees. Okay. In the next step, we will connect together points D and E by a straight line. Actually, by connecting together points D and E by a straight line, we created triangle DFE, and in triangle DFE we know that side DF equals to side FE. Again, in triangle DFE, side DF equals to side FE. So those two sides are equal to each other. So according to rule number 2 that states that in front of equal sides there are equal angles, those two angles are equal to each other. Those two angles are equal to each other. Okay? Because those two angles are located in front of equal sides, therefore, according to rule number 2, they are also equal to each other. So if we define angle EDF as y, then angle DEF will be also equal to y because of the fact that those two angles are equal to each other. Okay, and what is the sum of the angles in triangle DFE? It equals to 180 degrees. That's the sum of the angles in any triangle. According to rule number 1, the sum of the angles in any triangle is equals to 180 degrees. That is to say, y plus 60 degrees equals to 180 degrees, or 2y plus 60 degrees is equal to 180 degrees according to rule number 1. Okay. So in triangle DFA, we know that the sum of the angles is equal to 180 degrees. So we will subtract from this equality 60 degrees, and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. So we will divide this equality by 2 in order to get the value of y. Y will be equal to 120 degrees over 2 is 60 degrees. So we found out that the size of angle y is 60 degrees. Okay, so we can write here that angle y equals to 60 degrees. So this angle equals to 60 degrees, and this angle also equal to y, it equals to 60 degrees. So all the angles of triangle DFE are equal to 60 degrees, therefore triangle DFE is an equilateral triangle. That is to say, all of its sides are equal to each other. So side DF equals to side DE, this side equals to side DF equals to side EF. So if we define all the sides that I marked with 2 lines are equal to each other, so if this side is x, then FC also will be equal to x, and DF also will be equal to x, FE also will be equal to x, and DE also will be equal to x. Okay? So in the next step, we will find out the size of angle ADE, the size of this angle, and we will also find out the size of angle AED, the size of this angle. Okay? And again, we will use rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. AB is the side of triangle ABC, therefore it is a straight line. Therefore the sum of the angles at any point on the straight line AD must be equal to 180 degrees. That is to say, if we focus on point D, then according to rule number 3, B plus 60 degrees plus the size of this angle, angle ADE, must be equal to 180 degrees according to rule number 3. Okay? Again, B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 3. So we will subtract 60 degrees and B from this equality, and we will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees, and we subtracted also B from this equality, so it is 180 degrees, 120 degrees minus B. So the size of angle B equals to the size of angle ADE equals to 120 degrees minus B. But we have already found out that B plus C equals to 120 degrees according to equation number 1. So we subtract from equation number 1 B, and we will get that C equals to 120 degrees minus B. So we actually found out, according to equation number 1, 120 degrees minus b equals to c. So here we have 120 degrees minus b, and according to equation number 1, it equals to c. Okay, so from this equality, we can deduce that angle ADE equals to C. Okay, so angle ADE equals to C. So I can write in the drawing that angle ADE equals to C. Then we repeat on the same process on the other side of triangle ABC. Again, AC is one side of triangle ABC, therefore it is a straight line. And the sum of the angles along a straight line at any point is equals to 180 degrees. So actually C plus 60 degrees plus the size of angle AED, the size of this angle, must be equal to 120 degrees according to rule number 3. Again, C plus 60 degrees plus the size of angle AED must be equal to 180 degrees according to rule number 3. And again, we will subtract from this equality 60 degrees and C. We will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees, and we subtracted also C from this equality, so it is 120 degrees minus C. Okay, we got that angle ADE equals to 120 degrees minus C. And again, we have equation number 1 that states that P plus C equals to 120 degrees. So we will subtract C from equation number 1, and we will get that angle B equals to 120 degrees minus C. So we found out that 120 degrees minus C equals to B. So here 120 degrees minus C equals to B. So from this equality, we can derive that angle ADE equals to B. Okay, angle ADE equals to B. Okay, so we can write down in the drawing that angle AED equals to B. Okay. Okay, angle AED equals to B. So in the next step, we will prove that triangles ADE and triangle ABC are similar to each other. So we focus on triangle ABC, the big triangle, and triangle ADE. Actually, angle AED, this angle, in triangle ADE is equal to angle ABC in triangle ABC, and those two angles are equal to beta. Those two angles are equal to B, so and they are equal to each other, so angle AED in triangle ADE equals to angle ABC in triangle ABC, and those two angles are both equal to B. And also angle ADE in triangle ADE is equal to angle ACB in triangle ABC, and both those two angles are equal to C. Okay, I'll repeat again. Angle ADE in triangle ADE equals to angle ACB in triangle ABC, and both those two angles are equal to C. Again, both those two angles are equal to C, therefore they are equal to each other, and we have here common angle. This angle is a common angle. It belongs both to triangle ADE and also to triangle ABC, so we can write down that angle A equals to angle A, angle A equals to angle A, it is actually a common angle, okay. So we actually proved that all the angles of triangle ABC are equal to all the angles of triangle ADE. Therefore, we actually proved that triangle ABC is similar to triangle ADE. Triangle ABC is similar to triangle ADE according to angle similarity rule. And we read again the things that I wrote. Triangle ABC is similar to triangle ADE according to angle similarity rule. So when you prove that all the angles of one triangle are equal to all the angles of another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. So we actually proved that triangle ABC is similar to this triangle ADE according to angle similarity rule. We actually have rule number 4 that states it relates to similar triangles. Rule number 4 states that the ratio between similar triangles is equal to the square ratio of the corresponding sides. So I will read rule number 4 again. rule number 4 states that the ratio between similar triangles is equal to the square ratio of the corresponding sides. Okay, so according to rule number 4, the ratio between triangle ABC, the area actually rule number 4 states that the ratio between the areas and read rule number 4 again. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So actually rule number 4 states that in our two similar triangles that the area of triangle ABC, that is actually the sign for the area of triangle ABC. So the area of triangle ABC over the area of triangle ADE is equal to the square ratio of the corresponding angles. And the square ratio of the corresponding angles is actually BC squared over DE squared. Okay, so according to rule number 4, the ratio between the areas of triangle ABC and triangle ADE that are similar triangles equals to the ratio between the corresponding between the square it is equal to the square ratio of the corresponding sides. It equals to BC squared over DE squared. Actually, BC and DE are the corresponding sides, and according to rule number 4, it equals to the square ratio of the corresponding sides. That is to say, it equals to BC squared over DE squared. Okay? The ratio between the area of triangle ABC over the area of triangle ADE equals to the ratio between their sides, that is to say, it equals to BC squared over DE squared. Okay? And what is the value of BC? The value of BC is actually x plus x, it equals to 2x. So BC squared will be equal to 2x squared. And what is the value of the DE? DE equals to x, so DE squared equals to x squared. So the ratio equals to the ratio between triangle ABC to triangle ADE equals to 2x squared over x squared. 2x squared is 4x squared, and 4x squared over x squared equals to 4. Okay, so we found out that the ratio between the areas of triangle ABC to the area of triangle ADE equals to 4. Okay, so here we will multiply this equality by the area of triangle ADE, and we will get that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay. Again, the area of triangle ABC equals 4 times the area of triangle ADE. So, in the next step, we'll find out the area of quadrilateral DBEC, the area of this quadrilateral. Actually, the area of quadrilateral DBEC equals to the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE. So the area of the big triangle ABC minus the area of the small triangle ADE equals to the area of the quadrilateral DBEC. As you can see from the drawing, if we subtract from the area of the big triangle, triangle ABC, the area of the small triangle ADE, we get the area of the quadrilateral DBEC. Okay, so it equals the area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle ADE. This triangle, triangle ADE. Again, the area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle ADE. Actually, if we subtract the area of the big triangle if we subtract from ABC, the big triangle, the area of the small triangle, triangle ADE, we'll get the area of quadrilateral DBEC. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. So we can subtract the area of triangle ABC by 4 times the area of triangle ADE in this equality. Okay, so we'll get that the area of quadrilateral DBEC equals to 4 times the area of triangle ADE minus 1 time the area of triangle ADE. So 4 times the area of triangle ADE minus 1 times the area of triangle ADE will be equal to 3 times the area of triangle ADE. We actually found out that the area of quadrilateral DBEC equals to 3 times the area of the small triangle, triangle ADE. Okay, the area of quadrilateral DBEC equals to 3 times the area of the small triangle, green triangle, triangle ADE. And we have already found out that the area of triangle ABC equals to 4 times the area of the green triangle, triangle ADE. Okay, so in the next step, I will present to you the special formula for the area of any triangle. If we have triangle ABC, if we know that the size of side AB of triangle ABC is A units, we also know that the size of side AC of triangle ABC is B units, and we know that the angle between side AB and side AC of triangle ABC equals to theta. Then the area of triangle ABC, this triangle, will be equal to A times B times sine theta over 2. Again, the area of this triangle ABC, when we know that the size of side AB is A and the size of side AC is B, and the angle between AB and AC is theta, it equals to, the area equals to A times B times sinus theta over 2. Okay? So, we actually can implement this all in our two triangles. We know that the area of triangle EFC equals to 15 units and the area of triangle DBF equals to 8 units. So we will write down the ratio between the two triangles. The ratio between the areas of those two triangles is 15 over 8. 15 over 8. So 15 square units is the area of triangle EFC, and according to the new formula that I presented to you, the area of triangle EFC will be equal to x times sinus q over 2. Again, the area of triangle EFC according to the new formula that I presented to you will be equal to x times x times sine q over 2. Again, the area of the big triangle EFC will be equal, according to the new formula that I presented to you, that the area of this triangle equals to A times B times sinus theta over 2. The area of triangle EFC will be equal to x times sinus q over 2. Okay, the area of triangle EFC equals to x times sine q over 2. And in the same way, we can say that the area of the small triangle DBF, that equals to 8 square units, the formula for the area of this triangle is actually x times sine p over 2. X times sine p over 2. Again, the area of the small triangle equals to x times sine p over 2. The area of the small triangle equals to x times sine p over 2. So here we'll move these two to the numerator, and we will move this expression to the denominator. So we will get that 15 over 8 equals to x times x is x squared times sine q, and we will move this 2 to the numerator, that is 2 over 2 times x squared times sine p. We moved this expression to the denominator. So in total, we got that 2x squared times sine q over 2x squared times sine p equals to 15 over 8. So 2x squared over 2x squared is 1, so it is cancelled. So in total, we left with sine q over sine p equals to 15 over 8. Okay, again, sine q over sine p equals to 15 over 8, but we have equation number 2 that states that q plus p equals to 120 degrees. So we will subtract p from this equality, and we will get that, according to equation number 2, q equals to 120 degrees minus p. Okay, q equals to 120 degrees minus p, and we have our equality that states that sine q over sine p equals to 15 over 8. Okay, our equality states that sine q over sine p equals to 15 over 8. So here we have sine q, so we can substitute q by 120 degrees minus p, because q equals to 120 degrees minus p. Okay, so we will do it now. So instead of sine q, we will write down sine 120 degrees minus p, that equals to q, over sine p equals to 15 over 8. So here we have sine 120 degrees minus p. In order to calculate the value of sine 120 degrees minus p, I will present to you new trigonometric identity. Actually, the trigonometric identity is the expression for sine a minus b. According to this trigonometric identity, sine a minus b equals to sine a times cosine b minus sine b times cosine a. Okay, this is the trigonometric identity for sine a minus b. Sine a minus b equals to, according to this trigonometric identity, equals to sine a times cosine b minus sine b times cosine a. Okay, so we'll use this trigonometric identity in order to calculate the value of sine 120 degrees minus p. So we have this equality. So instead of sine, first of all, we will calculate the value of sine 120 degrees minus p. So sine, according to this trigonometric identity, sine of 120 degrees minus p equals to sine 120 degrees times cosine p minus sine p times cosine 120 degrees. Okay, so we found out that the value of sine 120 degrees minus p equals to sine 120 degrees times cosine p minus sine p times cosine 120 degrees. So it is actually equals sine 120 degrees is root 3 over 2 times cosine p minus sine p times cosine 120 degrees is minus 1 over 2 times cosine p. Okay, and here we have minus minus is plus, so we can write down that sine of 120 degrees minus p equals to root 3 over 2 times cosine p plus 1 over 2 cosine p. Okay, so we substitute sine 120 degrees in this equality by this expression, we will substitute sine 120 degrees minus p by this expression that equals to sine 120 degrees minus p. So here we have sine 120 degrees minus p. According to what we found, the value of sine 120 degrees minus p is actually root 3 over 2 times cosine p plus 1 over 2 times cosine p. Okay, all divided by sine p. Okay, so all equals to this equals to 15 over 8. So actually root 3 over 2 cosine p over sine p is cotangent p, and here we have 1 over 2 sine p over sine p is 1, so sine p is cancelled, and all equals to 15 over 8. Okay, so we actually found out that root 3 over 2 times cotangent p equals to plus 1 over 2 equals to 15 over 8. We have another trigonometric identity that cotangent p equals to 1 over tangent p. Okay, cotangent p equals to 1 over tangent p. Okay, here we substitute cotangent p by 1 over tangent p. We get that root 3 over 2, and we substitute we will substitute cotangent P by 1 over tangent P. Plus 1 over 2. 1 over 2 is 4 over 8 equals to 15 over 8. Okay, so here we will subtract 4 over 8 from this equality, and we will get that root 3 over 2 over tangent P equals to 15 minus 4 over 8. 15 over 8 minus 4 over 8. So in total we got that root 3 over 2 times tangent P equals to 15 over 8 minus 4 over 8. Okay. So here 15 minus 4 is 11. So in total we will get in this side of the equality 11 over 8. Or root 3 over 2 times tangent P equals to 11 over 8. Here we will multiply this equality by tangent P. We will get that root 3 over 2 equals to 11 over 8 times tangent P. So here we will multiply this equality by 8 and then we will divide it by 11 in order to get the value of tangent P. So tangent P will be equal to 11 over 8 times root 3 over 2. Here it is actually, I multiplied this equality by 8 and then I divided it by 11, so it is actually okay, tangent P equals to 8 over 2 times root 3 over 11. Again, tangent P equals to 8 over 4 times root 3 over 11. So we actually found out that tangent P equals to actually 4 over 2. Here we have 4 over 2. It is 4, 8 over 2. 8 over 2 is 4. Here 8 over 2 is 4. So it is actually 4 times root 3 over 11. Actually, we found out that tangent P equals to 4 times root 3 over 11. And you know that tangent P is actually the relationship between the sides of a right triangle. So if tangent P equals to 3 times root 3, then it means that in a right triangle that has angle P, that this angle is angle P, then the side that in front of angle P will be equal to 4 times root 3, while the side that is near angle P will be equal to 11, and here tangent P will be equal to 4 times root 3 over 11, exactly what we have here, and we'll find out the size of the hypotenuse according to the Pythagorean theorem that states that the square of the hypotenuse in a right triangle equals to the sum of the squares of the perpendiculars. So actually the hypotenuse square equals to 4 times root 3 square plus 11 square, that is the square of the hypotenuse. And if we want to know the size, not the square of the hypotenuse, but the hypotenuse itself, we will take a root and we will get the size of the hypotenuse. So here we will get that sine P equals to 4 times root 3 over the hypotenuse that equals to root 3 times root 3 square four times root 3 square plus 11 square. Okay, so we got that sine P equals to 4 times root 3 over 4 times 3 square plus 11 square. 4 times root 3 square is actually 16 times 3 is 48, and 11 square is 121, so I'm writing down. So sine P will be equal to 4 times root 3 over root of 48 plus 121. So sine P equals to 4 times root 3 over 48 plus 121 is 169. Okay, so actually sine P equals to 4 times root 3 over root of 169 is 13. So we found out that sine P equals to 4 times root 3 over 13. Okay, so we actually can use this data, the value of sine P, in order to find out the value of x squared, because we know that the area of triangle BFD, this triangle, equals to 8 square units, and the formula for the area of triangle BFD that equals to 8 square units is actually x squared times sine P over 2. And we know that the area of this triangle equals to 8. Again, the area of triangle, the small triangle BDF equals to x squared times sine p over 2 according to the formula that I presented to you. And we know that the area of this triangle equals to 8 square units. So the area equals to 8 square units. We have already found out that sine p equals to 4 times root 3 over 13. So we'll substitute sine p in this equality by 4 times root 3 over 13, because sine p equals to 4 times root 3 over 13. And we will get that x squared over 2 times sine p equals to 4 times root 3 over 13 equals to 8. So here 4 over 2 is 2. So we get that 2 times root 3 over 13 equals to 8. So here we will divide this equality by 2, and we will get that x squared times root 3 over 13 equals to 4. Here we will multiply this equality by 13, and then we will divide it by root 3 in order to get the value of x squared, and x squared equals to 13 times 4 over root 3. So x squared equals to 13 times 4 is 52 over root 3. So we found out that x squared equals to 52 over 3. In the next step, we will find out the area of the equilateral triangle, triangle DFE, the area of this equilateral triangle, triangle DFE. So actually, the area of any triangle according to the formula that I presented to you equals to x times sine 60 over 2. So it is x squared times sine of 60 degrees equals to root 3 over 2. But we must divide it by 2. Okay, so root 3 over 2 divided by 2 is root 3 over 4. So in total, the area of the equilateral triangle, triangle DEF, equals to the area of triangle, the equilateral triangle, triangle DEF, equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over root 3. So we'll substitute x squared by 52 over root 3, and we will find out the area of the equilateral triangle, triangle DEF. So the area of triangle D, the equilateral triangle, triangle DEF, will be equal to x squared, that equals to 52 over root 3, times root 3 over 4. Okay, so here we have root 3 over root 3 is 1, so root 3 is cancelled, and 52 over 4 is 13. So we found out that the area of the equilateral triangle, triangle DEF, equals to 13 square units. Okay, so we can write down here that the area of the equilateral triangle the green equilateral triangle DEF equals to 13 square units. So now we can find the area of the quadrilateral BDEF, because the area of quadrilateral BDEC, the area of this quadrilateral BDEC actually equals to the area of this triangle, that is 8 square units, plus the area of the equilateral triangle that equals to 13 square units, plus the area of triangle EFC that equals to 15 square units. So in total, the area of quadrilateral BDEC equals to 8 plus 13 plus 15. 8 plus 13 is 21, and 21 plus 15 is 36. Okay, so the area of quadrilateral BDEC equals to 36 square units, but we have already found out that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. Okay, the area of quadrilateral BDEC equals to 3 times the area of triangle ADE, and we know that the area, okay, we know that the area of quadrilateral BDEC, the area of quadrilateral BDEC equals to 36 square units. Actually, from this equality, we can derive that 36 equals to 3 times the area of triangle ADE, or 3 times the area of triangle ADE equals to 36 square units. Here we divide this equality by 3 in order to find out the area of triangle ADE, the green small triangle ADE. The area of triangle ADE equals to 36 over 3 is 12 square units. Okay, so the area of triangle ADE, this green triangle, equals to 12 square units. So actually we now can calculate the area of the green shape, or the green quadrilateral. The area of quadrilateral ADFE will be equal to the area of triangle ADE, that is 12 square units, plus the area of the equilateral triangle DFE, that is 13 units. Actually, 12 plus 13 is 25. So the area of quadrilateral ADFE equals to 25 square units. Okay, again, the area of the green shape, or the area of quadrilateral ADFE, equals to 25 square units. Okay, the area of this quadrilateral, the green quadrilateral ADFE, equals to 25 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green shape, or the area of quadrilateral ADFE. We know that in triangle ABC we have angle BAC that equals to 60 degrees, and we also know that BF equals to CF equals to DF equals to EF, and we also know that triangle BDF, this triangle, equals to 8 square units, and the area of triangle EFC equals to 15 square units. And we want to find out the area of quadrilateral ADFE, the green shape. Okay. So, first of all, I presented to you rule number 1 that states that the sum of the angles on the sum of the angles in the triangle is equal to 120 degrees. Again, we have rule number 1 that states that the sum of the angles in any triangle is equal to 180 degrees. The sum of the angles in any triangle is equal to 180 degrees. Therefore, the sum of the angles in triangle ABC equals to 180 degrees. That is to say, angle A that equals to 60 degrees plus angle B plus angle C equals to 180 degrees. Okay, 60 degrees plus angle B plus angle C equals to 180 degrees. We subtracted 60 degrees from this equality, equation number 1, and we found out that B plus C equals to 120 degrees. Then we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So again, in front of equal sides in the triangle there are equal angles. So if AB equals to AC, then angle ABC equals to angle ACB. Those two angles are equal to each other. So according to rule number 2, we have triangle BDF. In triangle BDF, we know that DF equals to BF. Okay? BF equals to DF. And in front of side DF, in triangle BDF, we have angle B. So this angle that is in front of BF must be also equal to B, because those two angles are located in front of equal sides. Therefore they are equal, they must be equal to each other. So if this angle is B, this angle must be equal also to B. So this angle BDF also equals to B. And the same thing, it is true in this triangle FEC. We know that FC equals to EF, and in front of side EF we have angle C. So in front of FC we have angle EFC. Angle EFC must be also equal to angle C. Those two angles must be equal to each other because they are located in front of equal sides. So if this angle is C, this angle must be equal also to C, according to rule number 2, that in front of equal sides in the triangle there are equal angles. Okay? And then we define angle BF DSP, and angle, this angle CFE is Q, and we actually expressed angle P in terms of B, and then we express angle Q in terms of C, because we know that the sum of the angles in triangle BDF according to rule number 1 equals to 180 degrees, that is to say B plus B plus P equals to 180 degrees, or 2B plus P equals to 180 degrees. We subtracted from this equality 2B, and we got that P equals to 180 degrees minus 2B. Then in this triangle FEC, we know that the sum of its angles is equal to 180 degrees, that is to say C plus Q equals to 180 degrees, or in other words 2C plus Q equals to 180 degrees. Then we subtracted 2C from this equality, and we arrived to the equation that Q equals to 120 degrees minus P, and we have already found out that P equals to 180 degrees minus 2B. So we added P to Q, or Q to P, and Q plus P equals to 120 degrees plus 120 degrees, that is 360 degrees, and it is plus minus C plus minus 2B, or plus minus 2C plus minus 2B, because plus and minus is minus, so it is minus 2C minus 2B. Then we took out minus 2 as a common factor of this expression, and we found out that Q plus P equals to 360 degrees minus 2 times B plus C. But we have already know that according to equation number 1, B plus C equals to 120 degrees, so we can substitute B plus C in equation number 2 by 120 degrees. We substituted B plus C by 120 degrees, and we found out that Q plus P equals to 120 degrees, and we have already found out that B plus C also equals to 120 degrees. Then we have rule number 3 that states that the sum of the angles on a straight line is equal to 120 degrees. Again, the sum of the angles on a straight line is equal to 180 degrees. So actually, in order to find out the size of angle EFD, we used rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. BC is the side of triangle ABC, therefore it is a straight line. Therefore, at point F, that is a point on a straight line, the sum of the angles must be equal to 180 degrees according to rule number 3. That is to say, P plus Q plus angle EFD must be equal to 180 degrees. Okay, P plus Q plus angle DFE must be equal to 180 degrees. But we've already found out that P plus Q equals to 120 degrees, so we can substitute P plus Q in this equality by 120 degrees. So we substituted P plus Q by 120 degrees, we got this equality, and from this equality we substituted 120 degrees, and we got that the value of angle, the size of angle DEF equals to 60 degrees. So this angle DFE equals to 60 degrees. Then we connected together points D and E by a straight line. We created triangle DEF. Okay, in triangle DEF, we know that DF equals to EF. Those two sides are equal to each other, so according to rule number 2, in front of equal sides in the triangle, we have equal angles. So those two angles that are located in front of equal sides also must be equal to each other. So if this angle is y, this angle must be also equal to y, because those two angles are equal to each other. So, and we know that the sum of the angles in any triangle, and especially in triangle DFE, equals to 120 degrees. So the sum of the angles is in triangle DFE is y plus y, this is 2y plus 60 degrees equals to 120 degrees. Then we subtracted from this equality 60 degrees, and we found that 2y equals to 120 degrees. We divided this equality by 2, and we got that angle y equals to 60 degrees. So this angle FD equals to 60 degrees, and angle FED, this angle also equals to 60 degrees. And actually, triangle DFE is an equilateral triangle. That is to say, all of its sides are equal to each other. So if one side is x, then all the other sides is x, and also the sides that are marked in two lines are also equal to x, because all the sides that are marked by two red lines are equal to each other. So all the sides here are equal to x. And in the next step, we calculated the values of those two angles according to the rule number 3, that states that the sum of the angles on a straight line is equal to 120 degrees. That is to say, we know that AB is the side of triangle ABC, therefore it is a straight line, and therefore at any point on the straight line AB, the sum of its angles is equal to 180 degrees. That is to say, B plus C plus angle ADE equals to 180 degrees. Okay? Again, and B plus 60 degrees, this angle is 60 degrees, plus this angle ADE, must be equal to 180 degrees according to rule number 3. Again, angle B plus the angle that equals to 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 3. We subtracted from this equality 60 degrees and also B, and we got that angle ADE, the angle that we are looking for, is equals to 120 degrees minus B. Then we have the equality that states that B plus C equals to 120 degrees. From this equality, equation number 1, we subtract B, and we got that C equals to 120 degrees minus B. So here, 120 degrees minus B equals to C, according to equation number 1. So from this equality, we can derive that angle ADE equals to C. Okay, so angle ADE, this angle equals to C. Then we repeated on the same process on the straight line AC. We know that the sum of the angles along the straight line AC at any point is equals to 180 degrees. That is to say, if we focus on point E, then actually angle B plus 60 degrees plus angle FEC equals to 180 degrees. Okay, so actually 60C plus 60 degrees plus angle AED equals to 180 degrees. And we know that B plus C equals to 180 degrees. So from equation number 1, if we subtract C, we get that B equals to 120 degrees minus C. So here we have 120 degrees minus C. According to equation number 1, it equals to C. So 180 degrees minus C equals to B. From this equality, we can derive that angle AED equals to B. Angle AED, this angle equals to B. Okay, so we found out that angle AED equals to B and angle ACD equals to C. Then we proved that triangles ADE, this green triangle and the big triangle ABC are similar to each other, because actually angle AED equals to angle ABC equals to beta. Angle AED in triangle ADE, this angle equals to angle ABC, and both those two angles are equal to beta, therefore they are equal to each other. And also we know that angle ADE equals to angle ACB, and both those two angles are equal to each other, are equal to C. Okay, both those two angles are equal to each other and they are equal to C. And also we have a common angle, it belongs to both to the green triangle, triangle ADE, and angle, that angle that equals to 60 degrees, it also belongs to the big triangle, triangle ABC. Therefore we can write down that angle A equals to angle A because it belongs to both triangles. Therefore we actually proved that all the angles in the big triangle, triangle ABC are equal to all the angles in the small triangle, triangle ADE. Therefore we actually proved that triangle ABC is similar to triangle ADE according to angle similarity. Okay, so triangle, the big triangle ABC is similar to the small triangle ADE, and we have rule number 4 that talks about the similar triangles. According to rule number 4, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Again, according to rule number 4, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Actually, according to rule number 4, the area of triangle ABC over the area of triangle ADE, that is the ratio between the areas of the two similar triangles, is equal to the square ratio of the corresponding angles, and the corresponding angles are BC and DE, and according to rule number 4, it equals to the square ratio of the corresponding sides, that is to say it equals to BC square to DE square. And we know that BC equals to x plus x, that is to say it equals to 2x, and DE equals to x. So BC equals to 2x, DE equals to x, so BC square is 2x square and DE square is x square. 2x square is 4x square, and 4x square over x square equals to 4. So the ratio between or the area of triangle ABC over the area of triangle ADE equals to 4, or triangle ABC is 4 times bigger than triangle ADE. Then we found out the area of quadrilateral DBEC. The area of quadrilateral DBEC equals to the area of the big triangle ABC minus the area of the small green triangle, triangle ADE. If we subtract from the big triangle ABC the area of the small green triangle ADE, we will get the area of quadrilateral DBEC. Okay, again, the area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle, the small triangle ADE. But we know that the area of triangle ABC equals to 4 times the area of triangle ABC, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. Okay, so we will get that 4 times the area of triangle ADE minus 1 times the area of triangle ADE equals to the area of quadrilateral DBEC. So we found out that the area of quadrilateral DBEC equals to 4 times the area of the green small triangle ADE. And we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay, then I presented to you a new formula for the area of any triangle. The area of this triangle is equals to A times B times sinus theta over 2. And we can use this formula to calculate the areas of these two triangles. We divided the area of the big triangle by the area of the small triangle, so it is actually 15 square units over 8 square units, and the area of the big triangle, according to the formula that I presented to you, is equals to x times sine q over 2. X times sine q over 2, and the area of the small triangle equals to x times sine p over 2. Okay, it equals to x times sine p over 2. So here 2x squared, we have 2x squared in the numerator and 2x squared in the denominator, so 2x squared is cancelled, and what is left is that sine q over sine p equals to 15 over 8. But we already know, according to equation number 2, that q plus p equals to 120 degrees. Or according to equation number 2, q equals to 120 degrees minus p, so we can substitute q here by 120 degrees minus q. So instead, by 120 degrees minus p. So instead of sine q, we write down sine 120 degrees minus p, all divided by sine p equals to 15 over 8. Then, in order to calculate the value of sine 120 degrees minus p, we used trigonometric identity that states that sine a minus b equals to sine a times cosine b minus sine b times cosine a. Okay, we used this trigonometric identity in order to calculate the value of sine 120 degrees minus p. And we found out that sine 120 degrees minus p equals to root 3 over 2 times cosine p plus 1 over 2 sine p. So here, after we found out the value of sine 120 degrees minus p, we substitute sine 120 degrees minus p by this expression that equals to sine 120 degrees minus p, and we solve this equality, and we found out that tangent p equals to tangent p actually equals to 4 times root 3 over 11. Actually, tangent p is the relationship between the sides in a right triangle. This is a right triangle, this angle is 90 degrees. So if tangent p equals to 4 times root 3 over 11, it means that the angle, the side that is in front of angle p is equals to 4 times root 3, and the side that is near angle p equals to 11 units. So in total we will get that tangent p equals to 4 times root 3 over 11. Then we calculated the hypotenuse of this right triangle according to the Pythagorean theorem, that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, and we found out actually sine p equals to 4 times root 3 over the hypotenuse, and we found out that the value of sine p is actually 4 times root 3 over 13. Then we used the formula for the area of this triangle in order to find out the value of x squared. We know that the formula for the area of this triangle is x squared times sine p over 2, that equals to 8. X squared times sine p over 2 equals to 8, because we know that the area of this triangle BDF equals to 8 square units. Okay, and we solve this equality, and we found out that x squared equals to 52 over root 3. After we found out the value of x squared, we calculated the area of the equilateral triangle DFE. The area of the equilateral triangle equals to x squared times root 3 over 4, but we have already found out that x squared equals to 52 over root 3, so we can substitute x squared by 52 over root 3 in this equality, and we found out that the area of the equilateral triangle DEF equals to 13 units. The area of this equilateral green triangle equals to 13 square units, and then we know that the area of the quadrilateral DBEC equals to the sum of the areas of triangle DBC plus the area of triangle DEC plus the area of triangle EFC. Okay, but we know that the area of triangle DBC is 8 square units, the area of triangle DEF equals to 13 square units, and the area of triangle EFC equals to 15 square units. So in total, the area of the equilateral DBEC equals to the sum of the areas of the three triangles, that is actually 36 square units. Okay, but we also note that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. And we also found out that the area of quadrilateral BDEC equals to 36 square units. So from this equality we can derive that 3 times the area of triangle ADE equals to 36 square units. We divided this equality by 3, and we found out that the area of the green triangle ADE equals to 12 units. The area of this green triangle equals to 12 square units, and we have already found out that the area of the equilateral triangle DEF equals to 13 square units. So the total area of the green shape equals to the sum of the areas of the two triangles, that is actually 12 square units plus 13 square units. So the area of equilateral ADEF, the green shape, equals to 12 plus 13. That is to say, the area of triangle of quadrilateral ADEF, the green shape, equals to 25 square units. Again, the area of this green shape, or the area of equilateral ADEF, equals to 25 square units. Okay, thank you very much.